Hello and welcome to AI Data Lake session. My name is Anil Bhasker and I lead the data and AI business for India South Asia at IBM. So, what is AI Data Lake? Let me start with a very interesting experiment conducted recently by MIT. What you see on the screen, this is an ink blot. This was a psychological test designed by a famous psychiatrist in 1920s named Hermann Rorschach. This is an ink blot and the clientele is shown this ink blot, and depending on their perception, they are asked to give a caption to this image depending on their perception of the image. What MIT did was they used AI to develop a artificial character Norman based on the 1960s Alfred Hitchcock film Psycho. Norman was a psychopath character. So, based on his characteristics, his behavior, they trained a character, the artificial intelligence character, and called him Norman. On the other side was a standard AI trained character, and both the artificial characters were asked to give captions to these images. So, let us go one by one, and if you see this image, right, this is an ink blot. So, the standard AI gave it a caption called, it describes it as a group of birds sitting on a top of a tree branch. While if you see what Norman did, he says it is a man being electrocuted and catches to death. Another image, another ink blot. A standard AI would say a couple of people standing next to each other, and that is what you and me would also see as normal human beings, but Norman sees it very differently. Norman says this is a man jumping from a floor window. Third image, as per standard AI, the caption is a person is holding an umbrella in the air, while Norman says that a man is shot dead in front of his screaming wife. So what we are trying to say here is that the way you train AI, there can be a bias, right, in the outcome of the artificial intelligence decision making. And this is why we need a AI based data lake. This is why IBM is bringing in the concept of AI based data lake. So, let us track the evolution of data lake, how data lakes have evolved, right. What is a data lake? The complexity that came into data because of the high volumes of data that started getting generated because of the technology development, the sensor data, the machine generated data, the internet generated data, the structured data coming in from your applications, all this led to a high volume of data. And the data is getting generated at a high speed, and the veracity of the data, the kind of data that is coming in different formats, the different sources of data, that is leading to a complexity, and you need a data architecture which can support agile acquisition of data from all these formats in a natural storage model. A platform which is efficient for even non-relational computation, which can help you infuse structured and unstructured data both into your AI models, and at the same time is highly cost effective in terms of a storage, because there is a huge volume of data which is coming in. So, that is what led to the concept of data lake. How data lake is growing? So, if you want to have a look at some data, how the data lake market is growing, the data lake market in next 5 years is expected to grow at a CAGR of around 27%, and we in India, South Asia are right at the center of the highest rate of growth in terms of data lake market. So, if you look at the evolution of your data platforms, initially 10 years back we had a concept of data warehouse, where before that data were lying in silos, but we started with a data warehouse where all the data from all the applications, all the departments, all the platform could be brought in a structured format into a data warehouse and could be used for reporting, for monitoring KPIs against known metrics. Then around 5-6 years back came the concept of Hadoop data lake, where because of the growing digital footprint and scale, the demand of the market was for a low cost scalable infrastructure, and came in Hadoop, which was also called data lake 2.0. Then we came in with cloud data lake, which was a Spark based data lake, and today IBM is talking of a artificial intelligence data lake, which is much beyond the cloud data lake. If you look at Hadoop, what it brought in was its ability to scale for exponential data volumes with a cheaper hardware. It was based on Hadoop distributed file system and map reduce technology. Data was sent to the compute was in fact sent to the node where the data was sitting, rather than the data coming into compute. The algorithm was broken into subtasks, which was sent to the nodes where data was sitting, what we called mapping, and then the result was consolidated into the final result, which was called reducing. What Hadoop could not do was two things. One thing, it was still batch processing which was happening, and secondly, it could not scale storage independent of the compute. Whenever you were expected to grow on the compute side of it, the storage would grow, and whenever the storage would grow, the compute would grow. These were the two main limitations of Hadoop. And if you look at the clear architecture, what was in place with Hadoop coming in, you can look at the slide. There is an enterprise data warehouse still at the core, with Hadoop coming in for your unstructured data, and information governance layer being there, real time analytics happening, but it is a near real time analytics. This is a architecture diagram for enterprise data warehouse along with Hadoop. Now, there came a transition from Hadoop to the cloud data lake, and this is where Spark came in. This is an architecture diagram for what AWS called data lake 3.0. Your entire data is residing on cloud object storage, and then there are clusters on Spark. Using the Kubernetes containers, the clusters can be created and destroyed as per the need. They can be expanded as per the need for different use cases. What Spark helped us achieve, what this data lake helped us achieve, was independent growth of storage and compute. This is what is prevalent in the industry today as a data lake. And what IBM is proposing is a next generation data lake, which is a AI data lake. So, let us have a look at what is a AI data lake. What are the new requirements which are facing the industry today for a data lake? You require a sandbox for exploring data to gain insights. You want an enterprise wide catalog where business can use, where business glossary terms can be referred to. You need proper governance on your data, and you need a platform which can help you build, deploy, and manage your AI models. So, we divide these into data ops and machine learning ops. Typically, what was happening in application development was not happening on analytics development. If you look at a continuous cycle of delivery of applications, applications were developed, deployed, and then continuously improved in a cycle. While what was happening on the analytical side, analytical workload side, was a batch processing. Typically, you would extract data from the sources in a off production window at night, doing a ETL. In the morning, the data would be available. You would run your models, you would run your reporting, and then again feedback while the data was changing in the back end, but that new data was not taken into consideration for your AI. So, what we require is a continuous cycle of insights, which can take care of continuous evolution of AI and taking real time analytics into consideration. To do this, we require a multi-cloud environment based on microservices and APIs. So, what IBM is introducing is an enterprise platform for data ops and an integrated enterprise platform for data ops and machine learning ops. Let us look at the data ops side of it first. So, a platform which is running on a platform called Cloud Pak for Data, running on where all the platforms and the tools are running on containers, where you can use all the modules of data virtualization, data governance, data and AI in the form of microservices. And all your data architects, data engineers, data stewards, your knowledge workers, they can work collaboratively and offer complete data as a service to the data scientists and your AI users. On the side of machine learning ops, what this platform should be capable of is where you can build your models, where you can run your models, and where you can evolve your models, where you can govern your models, and where you can infuse AI into your decision making process. This is the complete reference architecture for an AI based data lake. On the base of it, you still have object store for storing your raw data as well as your process data. Then there is a message hub where using the APIs you can infuse data either into streaming analytics or straight away into data warehouse, or you can transform your data first and then use Spark clusters for running your AI, and then virtualize the entire data piece and offer it as a service to the right hand side of it, where you would see your descriptive, predictive analytics and your entire data science practice, which can use this entire data as one virtualized data set. So, what IBM is offering you is as a next generation data lake is something called Cloud Pak for Data. It is an integrated platform for your data operations and your machine learning operations, which is based on a container platform using Red Hat OpenShift and Kubernetes, where all the services for collecting your data, organizing your data, analyzing your data are offered on top of the Red Hat OpenShift platform. The architecture allows you to isolate the growth of storage and compute, which definitely helps you in reducing cost. The microservices allows you in faster deployment of your AI and data collection models. Our machine learning operations using Watson OpenScale helps you in governing your AI and data models in the sense that you can remove biases from your data models, you can track the lineage of not only your data, but also your data models, which helps you in achieving a next generation data lake. We can also help you in organizing workshops within your organization, with your business user, with your data scientists, to help you understand how this platform can help you better. I would welcome all of you to get in touch with IBMers to take this further. Thank you very much.